As we continue in the first section of Unit 5, we will now begin to add fractions with unlike denominators, and in this lesson we will use modeling, pictures, and visuals. In the first video of Lesson 6, we will do this using fraction circles or rectangles and pattern blocks. And as we did in adding fractions with like denominators, we will examine two types of questions. Given a visual, determine the answer to a given addition calculation, and then given an addition calculation, we will represent it by modeling to determine the answer. So let's have a look at some fraction circles and rectangles. In our first visual here, we see that we have two circles, both drawn the exact same size as they must be here, so the holes are the same. In the first hole, we have a circle that's been divided into 4 equal sections, and 3 of those sections are shaded. In the second circle, it has been divided into 8 equal sections, and only 1 of those sections shaded. So what we are adding together here is 3/4 plus 1/8. Now we know that in order to add fractions, we need to have a common denominator. So if we liken that to our visual here, then we need to make sure that each whole has been divided up into the same number of equal sections. So let's have a close look at our two denominators, 4 and 8. Well, if I list my multiples of 4, 4, 8, 12, 16, and so on, I list my multiples of 8, I just need the first one, because 8 is common to both. So the LCD is 8. And what that means is that I need to split or divide both of these circles into 8ths. Well, the second circle, done. I need to divide the first whole into 8ths. There we go. Notice, of course, that the same amount of shading has taken place here. It has to be. But what I have now is that out of those 8ths, I have 6/8 shaded. So now we have 6/8 plus 1/8. And I'm going to take this 1/8 piece, I'm going to combine it into the one whole. So I'm going to move it over here. So now we have this picture, and we see that 7/8 are shaded when they combine. And 7/8 is simplest form. For our second example, we're going to use modeling to help us calculate 1/2 plus 2/5. This time, let's use some fraction rectangles to help us with this. So for my first rectangle, I'm going to make it 2 equal sections and shade 1. And for my second whole, the second rectangle, I'm going to have 5 equal sections and shade 2. Here we go. So this one represents the 1/2. A second whole drawn the exact same size, only this one represents 2/5. We know that in order to add, we need to have the same denominator. And as with models, we know that we need to have those wholes divided up into the same number of equal sections. So we take a close look now at our denominators to help us figure that out. So 2 and the 5. If I list off my multiples of 2, 2, 4, 6, 8, 10, 12, and so on. My multiples of 5, 5, 10, and look at there, I can stop. Got a 10 and a 10. So my LCD is 10, which means I need to divide each of these wholes into 10 equal sections with the same shaded region. There we go. So I notice now for the 1/2, that's the same thing as 5/10. And I notice for the 2/5, that's the same thing as 4/10. So 5/10 is an equivalent fraction for 1/2. 4/10 is an equivalent fraction for 2/5. And if we take this shaded part here and put it over into one whole, then we end up with, and if we count up those equal sections in that final whole, we see 9 out of 10 shaded. So 1/2 plus 2/5 equals 9/10. And that is simplest form. Let's look at some pattern blocks, and let's do the same type of thing. So again, we're going to use the model to determine the sum. So we look at our first whole, and we see that we have 2/3 shaded. We look at our second whole, we see that we have 1/6 shaded. Keeping in mind that the blue rhombus is 1/3, the green triangle is 1/6. So what we're trying to figure out here is 2/3 plus 1/6. If we were to combine all of our pieces into one whole, we get this. And you may be able to figure out your answer right just from looking at this particular picture. And that's great. What we're going to do, though, we're going to represent everything in terms of our smallest pattern block, the triangle. Keeping in mind that a triangle is 1/6. So if I was to take each rhombus here and put it into triangles, break it down into triangles, for each rhombus, I need 2 triangles. And of course, for the 1/6, it's already one triangle, so I don't need to do anything with that. And then if I combine all the pieces in one whole, there we go. And I see I have 1/6, 2/6, 3/6, 4/6, 5/6. So 2/3 plus 1/6 equals 5/6. And that is simplest form. Let's look at one more example. So now we're going to use the pattern blocks to help us figure out what 1/3 plus 1/2 is. So let's draw a picture for those two fractions first of all. So 1/3 is our one rhombus, 1/2 is our one trapezoid. If we were to put these pieces together into one whole, that's what we would have. So we want to figure out what the sum of 1/3 plus 1/2 is. What does this particular picture here actually represent? So we're going to take the same type of approach that we did in the previous example. Let's break everything down into triangles. There we go. If I combine all the triangles into one whole, I will get 5 triangles again in the whole, each triangle representing 1/6. So 1/3 plus 1/2, well, that too actually equals 5/6, which we know is simplest form. I would now like you to proceed to the next video in this lesson.